Now the test also likes to give you a bunch of remainders and see what you can pull out and what kind of insights you can find into number properties. It will come as absolutely no surprise to you that a couple English and math translations and a couple frameworks are going to put you in a spot where you're going to be able to nail any remainder question they can throw at you. Let's take a look. So when it comes to thinking about remainders and number properties, there are really two main ways to do it. And one is ratios, and the other is this goofy yet dead helpful equation, x equals yq plus r. Now let's take a look at ratios to begin with. Not surprisingly, ratios are totally about what you learned in 4th grade, and it works like this. If you were asked in 4th grade to take 27 and divide it by 4, you would probably do something like this. You'd do 27, you'd make this kind of funny half box thing, put 4 on the outside, and you'd say, well, let's see. 4 goes into 27 6 times because 4 times 6 is 24. So then you put it underneath the 27, you subtract, you get 3. And in 4th grade, you put your answer as 6 3/4. Well, here is the really, really helpful part. 3/4 is just a ratio. 3/4 is remainder over divisor. And because it's a ratio, it simply follows all of the ratio rules, which means r is a multiple of 3 and d is a multiple of 4. Now, I know that some people have probably tried to describe these relationships to you in very, very confusing ways. It's not really necessary for the test to understand the relationship beyond we got ourselves a ratio, and it's always remainder over divisor. That's the most useful way to think about this, and because that's true, they can ask you this. If A is divided by B, the result is 7.60. Which of the following could be the remainder? And then we're given 5 choices. Okay, well, as always, what are we being asked for? We are asked to try and find the remainder. Okay. So as we're looking at this, we don't care about the 7 part. That's not the remainder. That's how many times the thing went in evenly. We're interested in the 0.60 part. So let's see. 0.60 is the same thing as 60 over 100, or 6 over 10, or 3 over 5. So if we were rewriting this question in 4th grade, we would come to A is divided by B, and the result is 7 3/5. Well, 3 over 5 is just the remainder over the divisor, so the remainder must be a multiple of 3, and the divisor must be a multiple of 5. Now, what are we being asked for? Oh yeah, we're being asked for the remainder. We know it needs to be a multiple of 3. Hey, answer choice D is the only answer choice that is a multiple of 3. I know, honestly, it's as simple as that. Now let's talk about this very, very strange equation, x equals yq plus r, and this is going to come as absolutely no surprise to you. Most of this has to do with getting their very bizarre English into some pretty simple math. Now, if we're told x is divisible by 7, that's actually a pretty loaded statement to us, because that means all of these things. It means x contains all the DNA of 7. It also means that x over 7 is an integer, and it also means x equals 7q. The very, very same thing, x is divisible by 7, that is identical to x is a multiple of 7. Those things mean the same thing, and it's a little easier in that wording to see how x equals 7q. There's another way to say the exact same thing. 7 is a factor of x, and guess what that means? Yep, x equals 7q. Now, the reason this is helpful is because when you start to talk about remainders, x is divisible by 7 with a remainder of 5 in math, that turns into x equals 7q plus 5. For example, let's say q was 2. That would make x 19. All right, so you're looking at all these different ways to be able to say this, all these different ways to be able to express it in math. How do you know which one to use? Whenever they start talking about remainders, I want you to start thinking about x equals yq plus r. That will usually get you down the right road to get to the answer fast. One more thing about these remainders, the relationship between the remainder and the divisor. Remember, the remainder always has to be less than the divisor. So x equals 7 times 2 plus 9. The divisor is 7. Well, that's a little weird because that would mean that x is 23, and we've just said we're going to divide 7 into 23 2 times. That's only 14. Wait a minute. What that really means is that 23 is 7 times 3 plus 2. This idea that the remainder needs to be less than the divisor comes up quite a bit. And because all of this is true, they can ask you this question. If x is a positive integer, what is the remainder r when x is divided by 6? And they're telling us that r has to be greater than 0, so the remainder can't be 0. Okay, well, they're also giving us a couple statements, and the first statement is x produces a remainder of 9 when divided by 12, and the second statement is r is a multiple of 3. All right, as always, let's look back, see what the heck we've just been asked to find. We need the remainder. We need to figure out what the remainder is when x is divided by 6. And what do they give us in the question? Well, they tell us what is the remainder r when x is divided by 6, and in math, we're going to translate that to mean x equals 6q plus r. All right, now let's take a look at the first statement. So the first statement tells us x produces a remainder of 9 when divided by 12. All right, well, having stuff in English doesn't help us. What does that mean when we put it into math? Well, that means x equals 12q plus 9. All right, now how does that help us? Well, let's see. This x equals 12q plus 9, that statement can only produce a certain amount of x's. And when that statement produces x's, what is the remainder when those x's are divided by 6? In other words, we're going to see what x's we can create in equation 1, and then we're basically going to plug it into our original equation and see what our remainder is. So in equation 1, x equals 12q plus 9. If q equals 1, well, x is going to end up being 21. Let's plug 21 into our original equation, and what the heck is 21 divided by 6? That gives us a remainder of 3. Well, what if q wasn't 1? What if q was 2? If q is 2, that makes x 33. Let's take 33 and plug it into the original equation. 33 divided by 6 is going to give us 5, also with a remainder of 3. Well, let's say q wasn't 1 or 2. Let's say q was 3. If q is 3, then our x becomes 45. We plug that into the original equation, and 45 divided by 6 is 7 with a remainder of 3. I'm sold. Any x that equation 1 is capable of generating, when you divide that x by 6, you are going to get a remainder of 3. Statement number 1 is sufficient. Let's take a look at statement number 2. And statement number 2 kind of skips everything and just tells us that r is a multiple of 3. They're just telling us something flat out about r. Well, let's see. That means r could be like 3, 6, 9, 12, 15, 18, huh? Seems like r could be kind of anything. Oh, hang on, except the remainder must be smaller than the divisor. So we know that r must be smaller than 6. So that means if we had x equals 6q plus 3, well, yeah, that totally works. The remainder is less than the divisor. R must be 3. But what if x equals 6q plus 6? Well, that's a little strange. That's kind of like saying 24 divided by 4 equals 5 with a remainder of 4. No, that doesn't make any sense. 24 divided by 4 is 6 with a remainder of 0. Q just goes up by 1. So x equals 6q plus 6 has a remainder of 0. We just made q go up by 1. What about x equals 6q plus 9? Because remember, that remainder, we're told, is a multiple of 3. So I guess that remainder could be 9, except that doesn't make any sense because the remainder has to be smaller than the divisor. That's like saying 26 divided by 4 equals 5 with a remainder of 6. No, it doesn't work like that. 26 divided by 4 equals 6 with a remainder of 2. And that's the same thing here. This would actually have a remainder of 3. We've just made q go up by 1, and our 9 becomes a 3. X equals 6q plus 12. Well, that's the same game they're playing. That will actually give us a remainder of 0. Q is just going to go up by 2. Well, it looks like the only remainders we can generate here are 3's and 0's, and we're told that r can't be 0. So guess what? R must be 3. Very sneaky, but statement number 2 is sufficient. And we also know that statement number 1 is sufficient. Our answer is D. Very, very nice job. All of this remainder stuff is a little confusing. The ratio stuff tends to be a little easier to get your head around. This idea that the remainder must be less than the divisor and what that means can be a little tricky. Go over this question a couple times if you still find it challenging, and remember that this same question appears in the companion guide, and sometimes it's a little easier to go back and work through it when you can see it on a page. All right, good job, everyone.